This one's a little bit different because we see that there are two terms containing d in them. So what we want to do here is, if we're solving for d, we have to get all the d's together. This is going to become 7d after we combine like terms, minus the 3 is equal to 15. And then we're going to do what we've been doing before. We're going to add 3 to each side of the equation. That will give us 7d is equal to 18. And, 7 does not go into 18, but that's okay. We're going to rewrite this as a improper fraction, 18 over 7. Now, if we were to be checking our answer, when we substitute that 18 over 7 in, technically we would have to substitute it into both of those occurrences of d in the original equation, which makes this a little bit more work. If you were to substitute it into line 2, you'd notice that the 18 or the 7's would cancel automatically, just giving you 18 minus 3 equals 15. Now, that's not a complete check, however, because there was always the chance we made a mistake going from line 1 to line 2. If line 2 is true, then that would have been a proper check. So you decide what you need to do there. Number 6. On the left side of the equation, I notice that 8x minus 5x, those are like terms that can be combined. But I also notice on the right-hand side, we have some like terms that can be combined. So 8 minus 5 is going to give us 3x plus 3 equals, and on the right side we're going to subtract and get 15. Now we've got a nice, neat two-step equation. We're going to undo the addition of 3 by subtracting 3 on each side. That will give us 3x is equal to 12. And then in the process of dividing by 3 on each side of the equation, we will then have our solution, x is equal to 4, which we can check. Notice if we substitute it into that top line there, 8 times 4 makes 32. 5 times 4 is 20, so minus 20 plus 3, we're checking, is that question mark over our equal sign equal to 21 minus 6, which is 15. This becomes 12 plus 3 equals 15, and you can see that indeed 4 is the solution to that equation. In problem number 7, I upped the ante a little bit. Notice how we have variables showing up on each side of the equation. We need to solve for h still, but we have to decide which h we're going to solve for. Most people like to bring their variables to one side of the equation, or preferably to the left side of the equation, and that would mean subtracting the 7h's off of the right and thus off the left also, giving them negative 11h plus 9 is equal to 6, and then we can solve it from there. Subtract 9 from each side of the equation gives us negative 11h equals negative 3, and finally dividing each side by negative 11 gives us positive 3/11 as the solution to the equation. Now, you might have the question in your head, what if I didn't subtract 7h on both sides? Let me rewrite the original problem here for you, and let's pretend that you wanted to get rid of the h's on the left. We wanted to add 4h to the left to undo the minus 4h. Well, we would then add 4h to the right hand side. We would have 9 is equal to 11h plus 6, and then we would subtract the 6 on each side of the equation. That would give us positive 3 is equal to 11h, and you can see that after we divide by 11 we're going to get the same solution. H is equal to 3/11. Now, which is a better way to go? The answer is there isn't a better way. Some people say they always like to have their h on the left. Other people say, you know, I like to have a positive number in front of my h. I like having that positive 11h, whereas over here on the left I would have had a negative 11h, and then I don't have as much worries with signs. You decide for yourself where your comfort level is and go with that. I personally kind of switch back and forth between the different methods, but in front of the class I generally will make the variable go to the left hand side because most people feel a little bit more comfortable with that.